For our project, we made a convolutional neural network that predicts whether the given image contains a dog or a cat. We used keras from TensorFlow library to create our neural network. We use TensorFlow and keras because they are extremely popular with a lot of easy to find explanations and tutorials. We also followed two tutorials to be able to complete our project. Their links will be in the description below.
Before we do the demo, I'm going to talk about some of the important parts of our code. First off, we use a function called ImageDataGenerator from keras. This function allows us to randomly modify the images we use. For example, our images had a chance to be randomly mirrored horizontally, zoomed in on, and rotated within a 15-degree range. We do all this to avoid overfitting. Our dataset was about 25,000 images, so the chance of overfitting was low, but it's still good practice to take measures to avoid it. Next important part is our model. The tutorial we followed had us use the keras sequential model, which according to keras documentation is good for simple, multi-layer models where each layer contains one input and one output tensor. The input shape of the layer corresponds to the size of the image, which was 256 by 256, and the fact that we are using full RGB, which is the 3 at the end. Our model alternates between convolutional layers and pooling layers. This is done because the pooling layers reduce the size of the data by summarizing the regions created by convolutional layer, thereby reducing the computation amount as the model progresses through the layers on that image. Next, the data is flattened into a 1D array so that it can be used by the dense layer. The dropout layer is another safeguard against overfitting. Finally, the dense layer is the output layer. It uses a softmax activation function that makes sure that all of the probabilities of the neuron sum up to 1. In our case, it should be that the probability of being a cat plus the probability of being a dog equal 1. Now for the demo. First, I'm going to show the neural net being trained. The first thing we can see are the training set and validation set sizes, which are 20,000 and 5,000 respectively. Next is the neural net model, which shows the layer, output shape, and number of parameters, which are the number of elements the model can learn from at each layer. This next part is where the actual learning takes place. As you can see, this is epoch 1 of 20. This indicates the batch that is currently being processed. Each batch contains 30 images, so each epoch will go through 30 images per batch times 666 batches. The entire training will go over 30 images per batch times 666 batches times 20 epochs, which is about 400,000 images. Obviously, this means going over the same images many times. This is why the overfitting precautions previously mentioned are important. On this side, there's the time until the current epoch is done, the loss, and the accuracy percentage. These get updated on every batch. As the model goes through batches, it continues to learn and gain accuracy. This graph shows the loss and accuracy for the training set and validation set. Our model has about a 90% accuracy. So finally, we have the demo of the actual model. The image the model is predicting right now is that of a dog. And here the model predicted correctly. The number next to the dog is the probability that this is in fact a dog. Now we're going to try the image of a cat. Which should pull up correctly that yes, this is in fact a cat, and it also has a 99% probability that this is a cat. The model has a 90% accuracy. So it is not perfect. Image I'm pulling up right now is a cat. However, the model predicts it to be a dog, with a 60% probability of it being a dog. It's lower than the other two probabilities that we've seen, but it is still incorrect as it's leaning in the dog's favor. I'd like to very quickly point out the limitations of this model. There must be a cat or dog in the image, otherwise the prediction is nonsensical. Also, we did not train for a cat and dog in the same image label, so trying to predict for a cat and dog in the same image also gives a useless prediction.